Good morning, everyone, and welcome to the Change Makers, our open conversation series on innovation in the stainless steel industry. Today, we are pleased to welcome Sari Saidlou, Chief Battery Program Officer at Aperam. She will explain how she contributes to transforming Aperam, a stainless steel producer, into a key disruptor for electric vehicle battery housing. Hello, Sari. Welcome.
Hello, Eleanor.
So, first of all, Aperam is a key player in stainless steel, but like many other hidden champions, it's not so well known. So please tell us more about the company.
Okay, so Aperam is a leading stainless steel and alloys manufacturer with two main production sources, one in Europe and the other one in South America, and with operation in more than 40 countries. We are well recognized for our innovation mindset with more than 150 researchers in 3 dedicated research centers who are improving our product and manufacturing process.
So you mentioned R&D. You have a background within R&D, right?
Right. I have spent 15 years in the R&D at Aperam after several positions in the automotive industry, and my latest role in R&D was head of R&D. But as my motivation is really focused on innovation, I was appointed recently as Chief Battery Program Officer.
And what does the position of Chief Battery Program Officer have to do with the stainless steel industry?
So you look surprised, but in fact, it makes a lot of sense. Today, we are talking about the battery housing. So the battery housing is the packaging of the whole system of the battery, so module, cells, and all the electronics. Today, the material commonly used are carbon steel and aluminum. Stainless steel could offer a lot of technical advantages, but is often seen as too expensive. And our last studies showed that it's not true, and that we are able to meet all the specifications of OEM with a significant lower cost as compared to other material. It's because of those results and because the market is growing very fast that Aperam created a specific organization and then my position.
So knowing that, what are the main challenges that you're facing today in your mission?
So firstly, my main mission is to explore the different possibilities of matching the stainless steel properties and the market needs, guided by the pain point of the customer. So for that, I have to combine the economical and technological dimension and to determine the right product. Product meaning the grades for stainless steel, so the chemical composition and the microstructure, but also the shape in which we deliver the product. Coils could be very relevant for some OEMs, but we will not be useful for others, and they will need some semi-finished or even finished parts. So it's the way that I have to work to make the offer to the market. However, there are a lot of preconceived ideas about stainless steel, and in particular in the automotive industry. So if I have to summarize, I would say that my main mission is to break the preconceived ideas.
And what are those preconceived ideas and how do you break them?
So the main one is that stainless steel is too expensive. And I think that the best way to break it is to demonstrate that it's not true. So speak with data. And for that, we decided to tackle this cost challenge with considering 5 different functions, the main function of the battery housing. So first, the crash resistance. Second, the weight saving. Third, the fire resistance. Fourth, the manufacturing process. And the last but not least, the sustainability through the life cycle assessment. It is in this framework that we design 2 different battery housing concepts to really show the cost effectiveness of stainless steel.
And can you tell us more about those battery housing?
Yes, sure. So the first one is really oriented on the weight saving and has a strong contribution to the vehicle structure resistance. We we succeed to meet the 69 kilograms for this segment vehicle, which is the level of aluminum solution today. And we are significantly most effective in terms of cost. The second one is more oriented towards the future. For this one, we focus on the volumetric energy density and on the easy access for repair and maintenance, so easy access to the modules. And for this one, the idea was really to use the high formability of the stainless steel to be able to make some very complex shape.
So you mentioned concepts. Does that mean we are only at the concept stage and these innovations are not yet present in vehicles?
Not at all. We push the limit to demonstrate all the benefits of the stainless steel, but we have already many parts on the market today, in particular due to the very good properties of the stainless steel for thermal insulation and high formability. But in addition to that, for some markets where the safety and the durability are key, such as the heavy-duty truck, we have already a full system in stainless steel. So we are not at the low technology readiness level, but really optimizing the solution with our customer.
So now let's go back to sustainability. How sustainable is stainless steel?
So stainless steel is fully recyclable, and one of the assets of Aperam is to use high ratio of scrap, above 85% and up to 98%, which is huge. And in addition to that, our melt shop are equipped with electrical arc furnaces, which allow to decrease the CO2 footprint of our slab. And we are at one of the lowest in the market with 0.32 tons of CO2 by ton of stainless steel produced, which is very important for the future regulation on the heavy markets.
Well, this is indeed a very fascinating subject. Thank you very much, Sari, for sharing your experience at Aperam. Materials play an enabling role in applications that may seem mundane, such as battery casings, yet it's clear how much they require highly specialized metal expertise. Well, see you soon for new episodes of The Change Makers. And in the meantime, don't hesitate to contact Sari if you want to continue this conversation.